All right, so I'm going to solve for 4B practice. I'm going to solve each one with the discriminant, and then I'm also going to show you by graph. So let's get started. So for A, first thing you need to know is that the equation equals 0. Perfect. It is in standard form. So now we have the A is 4, the B is -5, and the C is 1. So we do B squared, so -5 squared minus 4 times A, which is 4, times C, which is 1. -5 squared is positive 25. Always anything squared is positive. Minus 4, -4 times 1, 4 times 1 is -16, which equals 9. 9 is a positive number, so that means there are two real solutions. Two real solutions. Number 2, and I'll do the graphs after. Number 2, we again evidence standard form, it equals 0, so A is 9, B is -3, and C is the constant. And so we have B squared, so -3 squared minus 4 times 9 times 7. Ooh, that's a big number. -3 squared is 9. 4 times 9 times 7. Oh boy, I don't know that off the top of my head. 36 times 7, 42, 4, 252. 9 minus 252 is -2, 4, 43. So that's a negative number, so that means there's two complex solutions. Two complex solutions. Number 3, we got to be careful right away. It's not equal 0, so we need to make it equal 0. So get our like terms together. The constants are like terms there, the numbers. So we have we know what our A is. A is with the x squared term, B is with the x term, and C is the constant all by itself. So we do opposite or B squared, not opposite. B squared minus 4 times A times C. We have 4 squared is 16. I always take this as a -4 times -3. I always take it as a -4, always. And that's a positive 12 times 7 is positive 84, I believe. I don't have a calculator on top right here, so that equals 100. 100 is a positive number, so two real solutions. So if we worked this all out, we'd get worked it all out of the quadratic formula, you'd get two real solutions. Number 4, looks like we don't have it in standard form. Let's get it in standard form. We don't have any like terms, but we're going to move everything to one side. Put it in standard form, so biggest exponent to the smallest. The n here is to the first power. So you go 2, 1, and then actually the constant has a power of 0, n to the 0 power. But we don't have to get into that right now. A, so the n squared term is A. The B, the coefficient of the B term, or the n term is B, and C is the constant. So we do this, let's do this. So we do B squared minus 4 times A times C. So -4 squared is 16, and -16 is 0. Oh, that tells us there's one real solution, and that the solution is a double. It's going to be called a double solution, and so it's because there's the biggest exponent is 2. We know there's going to be two solutions, and because there's only one real solution, it is called a double solution. So whatever the solution is, there's actually two of them. All right, number 5. We got to look into this a little bit closer here. We have, we don't have, it's not standard form at all. So it doesn't matter which side of the equation equal sign you go to. I'm just gonna, I noticed that if I add 7p squared, that will give us a positive 3p squared. Does not matter. I try to keep the A positive, but really does not matter. We're gonna subtract 1. Get those together, so that becomes -3. This 3p squared is positive, so I'm going to put a plus there. And lastly, we have add 9p to the other side, and those look like they just cancel out. So actually everything here simplifies out to 0 equals, and we have a -3 plus 3p squared. All right, we got to be a little careful with this. What our A, B, and C is. A is 3, positive 3. B, we don't have a p term or like the x term, so B is actually going to be 0 since it's not there. And then C is going to be negative 3. Tricky. So b squared, 0 squared, minus 4 times a times c. So you have 0 squared is 0. Negative 4 times 3 times negative 3 is a positive 12. 12 is a positive number, so we're going to have two real solutions. Number 6, again, not in standard form. Don't always see it in standard form. Those are not like terms. I'm not lining up the negative 7x squared or negative 7x. I'm just trying to make room for the 9. We now see that the a is 9, the b is negative 7, and the c is positive 9. So we do negative 7 squared minus 4 times 9 times 9, 49. Oh, I don't know what 81 times 4, and I know it's negative 4, 324, so minus 324. I can tell you that is definitely a negative number, so 24, 25, so I believe it's negative 275. Again, I don't have a calculator, so I'm just doing that quickly in my head just for time. And that's a negative number. I guarantee it's a negative number, so it's going to be two complex solutions. All right, number 7, we can work on that. It's y equals. It's the same thing. You can set y equal to 0, which is meaning when anytime y is equal to 0, that means you're looking on the x-axis. Anywhere along the x-axis, the y equals 0, like negative 3, 0, negative 2, 0, negative 1, 0, negative 3.5, 0. The y is always 0. So once you find where the y is 0, you can find the solutions, because the real solutions lie along the x-axis. So we have a is 1, negative 1. B is negative 6, and C is negative 8. So opposite of B, or B squared minus 4 times A times C. A lot of negatives flying around here. We can handle this. Negative 4 times negative 1 is positive 4, times negative 8 is negative 32, which is 4, which means there's two real solutions. This is positive 4. All right, let me erase that. Getting a number negative 8 or number 8. So this is not in standard form. To get it in standard form, it's a little bit of a process. I'll show you how to do that. We have y equals x minus 3 squared plus 2. It's not in standard form yet. What you have to do is x minus 3 squared. That equals x minus 3 times x minus 3. And then after you simplify, you'd have to add 2. So we have to multiply this out, gather like terms. So x squared minus 3x plus 9 plus 2. Gathering all your like terms, x squared minus 6x plus 11. There, now it's in standard form. Now we can tell our a, b, and c. A is 1, b is negative 6, and c is 11. So let's look at that. So we have b squared. I'm going to do it on the right side. B squared minus 4 times a times c. 36 minus 44 is a negative 8, which means there's two complex solutions. So when it comes to the graph, we will not see across the x-axis at all. All right, number 9, if you're working on that one, we have f of x equals 3, x minus 4 squared. We need to, order of operations, we need to do that first before we multiply by 3. So now I have it written out as multiplication. So you can actually multiply in any order you want. I still multiply the binomials first. That's what I do. You don't have to. Minus 4x plus 16. And then distribute it into 3 to each term. Well, let's get those like terms together. Now let's distribute this 3 into all the terms. 3x squared minus 24x plus 48. All right, here we go. There's our A. There's our B. And there's our C. B squared, negative 24 squared minus 4 times A times C. I'm going to have to get calculator for this. I was not planning on doing this way, but we have 24 squared, 576. 4 times, so 12 times 48. Oh, 576. That equals 0. So this means there's one real solution. All those big numbers, they all simplify down to 0. And that means that solution, when we look at a graph, it will actually turn right on, it'll be the max or minimum point of a graph when we look at that. All right, last one. We subtract 1. Weird looking. Both of those simplify out. That's super nice. Negative x plus 3 squared now. I'm going to change the color so it doesn't blend in with the bottom one. And this is a negative 1. We have to do the squared first before we multiply in the negative 1. X plus 3 times x plus 3. When you multiply that out, you get x squared plus 3x plus 3x plus 9. Gather your like terms before you multiply the negative 1 in. You don't have to. You can absolutely multiply the negative 1 in right away. And now distribute that negative 1. Negative 1x squared minus 6x minus 9. It just changes the terms. So we have A is negative 1, B is negative 6, C is negative 9. Not giant numbers, so that's great. Let's do it. Negative 6 squared minus 4 times A times C. A lot of negatives, though. 36, negative 4 times negative 1 is positive 4 times negative 9 is negative 36. Another 0. One real solution. So this one, again, when you graph it, will bounce off or turn. The maximum or minimum point will be on the x-axis. That's a double solution. All right, let's take a look at these graphs. No, wrong one. I think I just clicked on the wrong one again. Yes. Here, sorry. So looking at the first equation, there's 2 real solutions. It crosses the x-axis twice. Boom, boom. Second one. Second graph. Well, it doesn't cross at all, so that number 2 does not cross the x-axis, so that's 2 complex solutions. Number 3 crosses the x-axis twice, so it has 2 real solutions. Number 4 touches the x-axis just once, and this is a double solution. It's where the graph, the minimum or maximum point hits the x-axis, forms a quadratic at the x-axis, so it's a double solution. So it's one real solution, but it's a double. Here we have 2 real solutions. Number 5, number 6. Where's the darn graph? Well, number 6 is way up. It's not touching the x-axis, so that's 2 complex solutions. Number 7 has 2 real solutions, hits the x-axis twice. Number 8 doesn't hit the x-axis at all, so number 8 should be 2 complex solutions. Number 9 looks like it hits once at 4, so there's only 1 real solution, but it is a double solution. And hopefully number 10, yes it is a double solution also at -3. So please come to class. Any questions you have, just